Today we are going to do some exercises in series parallel circuits. We have to do a fair number of these because this is something we have to master before we can move on to bigger and better things and real-world electronic circuits. We're going to pick up where we left off in the electron series parallel circuits with a similar circuit. We have a battery, a resistor in series with that battery, then we have a parallel section where there's multiple current paths. But in that section we have two resistors where there's only one current path between them, so they are in series. So we have a series section, a parallel section, and then another series section. This looks a little more cluttered because I've added some labels and I've added two test points for us to find the voltage at. Remember, when we ask for the voltage at a point in a circuit, we are assuming that our black lead is anchored at a suitable point. In this case, that will be the negative side of this battery. Also, this line represents a wire or a trace on a circuit board, and we assume that there is no resistance anywhere along that wire. So, since there's no resistance, there can be no voltage difference. Remember, to get a voltage difference, you must have current and resistance. There is current flowing through there, but since there's no resistance, there's no voltage difference anywhere. So I can put my black lead anywhere along this wire, and it's the same as putting it on the negative terminal of the battery. That's the same as a real-world circuit. You can put the black lead of your voltmeter anywhere that connects directly to the negative side of your battery, and that's the same as having it connected directly to the negative side of your battery. So when I ask for the voltage at test point 1, I'm assuming that my black lead is somewhere along here, so it might as well be here. So I'm putting my black lead here, and I'm measuring with my red lead here. And so the voltage at test point 1 is actually the voltage across R2. Same thing for test point 2. We have this wire. I assume that my black lead is here, and my red lead is here. So the voltage at test point 2 is the voltage across R4. And we're going to look for the total resistance, the voltage at test point 1, the voltage at test point 2, the current through R2, the current through R4, and the total current. Let's put some values here and work a problem. For our first circuit, we have a 20-volt battery, 3 5-ohm resistors, and a 10-ohm resistor, and we want these values here. Total resistance, voltage at test point 1, voltage at test point 2, the current through R2, the current through R4, and our total current. Pause the video and solve the problem, then we'll work it together. To begin with, the easiest place to start is going to be finding the total resistance between these two resistors. They're going to act together as a single resistor. So let's redraw the circuit down here as it would if we zoom out and combine these into one single resistor. So let's redraw that. So these two resistors in series, we add the resistances together to get the total resistance, and they now act like a single resistor that is in parallel with another resistor, and so we have two 10-ohm resistors in parallel with each other. Now we can work these out to find out how they work together, and of course if we have two equal resistors in parallel, the total resistance is half of either resistor. So now these two resistors act like a single 5-ohm resistor. Now that we have these two resistors, we can add them together to find out what the total resistance of the circuit is. So 5 ohms plus 5 ohms is 10 ohms, so our total resistance is 10 ohms. Let's put that up here. Now with our total resistance and our voltage, we can calculate the total current. So we have 20 volts and 10 ohms. If you know your voltage, you divide into it. So we divide 10 ohms into 20 volts to get 2 amps for our total current. And let's put that over here. So now we have our total current of 2 amps and our total resistance of 10 ohms. Now we can start working out other parts of the problem. Let's tackle test point 1. While we have this circuit here, we can easily figure out what that voltage is because we have two equal resistors, so there will be equal voltage across these resistors, and those two voltages must add up to 20 volts. So we lose 10 volts here and 10 volts here. So looking back at the original circuit, we start with 20 volts, and we lose 10 volts here, leaving us with 10 volts there, and we lose the other 10 volts across the rest of the circuit. So the voltage at test point 1 is 10 volts. Now let's tackle the voltage at test point 2. We have here two equal resistors again, two 5 ohm resistors. We're starting with 10 volts, and we lose all 10 of those volts across those two resistors. So once again, we have equal voltage across equal resistors. So we must have 5 volts here and 5 volts here. So we start out with 10 volts, we lose 5 volts with 5 volts left over. Now all we have left is the current through the two legs of the circuit. Let's zoom back in on this and expand this resistor back out to its two resistors in parallel. So once again, these two 5 ohm resistors act like a single 10 ohm resistor, which is in parallel with the other 10 ohm resistor. So our current flows from the battery and splits at this point going two different directions, and it's 10 ohms in both directions. So we have equal resistance, so we'll have equal current. So we have 2 amps coming in, 1 amp goes this way, and 1 amp goes that way. That gives us the currents through the two resistors, which is 1 amp each. And now we have all of the things we were looking for. Let's do some checks with Ohm's law to make sure we got this right. So we start with 20 volts and we lose 10 volts to have 10 volts left over. So we should have 10 volts across this resistor. So we have 2 amps flowing in this part of the circuit. So 2 amps going through 5 ohms. How much voltage difference will there be across that? If you don't know your voltage, you multiply. So we have 2 amps times 5 ohms gives us 10 volts. So we start with 20 volts, we lose 10, have 10 left over. That is correct. Let's check the voltage here. We have 1 amp going through a 5 ohm resistor, so 1 amp times 5 ohms gives us 5 volts. So we should have 5 volts across this resistor, which will be the voltage at test point 2, and there it is correct. We should have the same thing here. 1 amp through 5 ohms should give us 5 volts here. We start with 10, we lose 5, with 5 left over, and it works out. So the circuit balances out and we got it right. Okay, here's the same configuration with some different numbers. Looks a little more complex. Let's see if it is. We have 27 volts, 18K, and 30K and 60K and 10K in the same configuration. We want the total resistance, voltage at test point 1 and 2, total the two different currents, and the total current. Pause the video and solve the problem. Let's tackle this the same way. We have a 30K resistor and a 60K resistor in series with each other, so together that's a total of 90K. Let's put that in our equivalent circuit down here like we did before. So now we see that we have 30K plus 60K is 90K, which is in parallel with 10K. So let's work that out and find out what its total resistance is and how it interacts with the rest of the circuit. So we have 10 times 90 divided by 10 plus 90 gives us 9K together. Now that 9K is in series with 18K, giving us a total resistance of 27K. Now that we have our total resistance, we can calculate our total current. So we have 27K and 27 volts. If you know your voltage, you divide into it. Remember, kilo ohms into whole volts gives us an answer in milliamps. So 27K into 27 volts gives us 1 milliamp, or 27 volts divided by 27,000 gives us 0.001 amps, or 1 milliamp. Now, while we still have this here, let's figure out our voltage at test point 1. We have 18K and 9K, so we have twice the voltage here as we do here, and those two voltages must add up to 27 volts. So what would that be? We would have 9 volts here and 18 volts here. So since the voltage at test point 1 is merely the voltage across this resistor, that means the voltage at test point 1 is 9 volts. Now let's tackle the current through the two resistors. Let's expand this back out to the two resistors in parallel. So now we have our 90K resistor in parallel with our 10K resistor. We have 9 times the resistance, so it will have 1/9 of the current. So this will have 9 times the current that this has, or this leg will have 9 times the current of that leg, and those two currents must add up to 1 milliamp. So we will have 0.9 milliamps here and 0.1 milliamp here. Now I could express these in microamps because 0.9 milliamps, or 0.0009 amps, is 900 microamps, or 0.1 milliamps, or 0.0001 amps, is 100 microamps. But we don't want to confuse the issue by having different units in different places of the circuit. So we'll stay in milliamps. So 0.9 milliamps, 0.1 milliamp, and so now we have the currents through the two legs of the circuit. Now let's look at the voltage at test point 2. We have 9 volts across these two resistors, 9 volts from here to here, which is the same as 9 volts from here to here. So 9 volts, and the resistors are a 2-to-1 ratio. We have twice the resistance here as we have here, so we have twice the voltage here that we have here, and those two voltages must add up to 9 volts. So we're going to have 6 volts here and 3 volts there, and so the voltage at test point 2 is merely the voltage across here, so we have 6 volts here, which is the voltage at test point 2. Now let's double check with some Ohm's law. We have 1 milliamp flowing through 18 kilo ohms, so if you want your voltage, you multiply, so 1 times 18, remember, milliamps times kilo ohms gives us an answer in whole volts. So 1 milliamp times 18K gives us 18 volts, which is the same as 0.001 amps times 18,000 ohms gives us 18 volts. We start with 27 volts, we lose 18 and have 9 left over, so that works. Now let's check the voltage here the same way. We have 0.1 milliamp going through 30K. Once again, milliamps times kilo ohms gives us an answer in whole volts. So 0.1 amps times 30 kilo ohms gives us 3 volts, or 0.0001 amps times 30,000 ohms gives us 3 volts. So 9 volts minus 3 volts gives us 6 volts. So it works out. Okay, let's do one more like this for practice before we move on to something more complex. We have 180 volts, 48K, 40K, 20K, and 40K. Same configuration, same information. Pause the video and solve the problem. Let's approach this the same way. Let's find the total resistance between these two and draw our equivalent circuit down here. So we have 20K and 40K. Together those will be 60K. And so we'll draw that down here. So 40K plus 20K gives us 60K in parallel with 40K. So let's work that out. 40 times 60 divided by 40 plus 60 is 24. So this altogether is 24K. Now we can add these together to find the total resistance. 24 plus 48 is 72K for our total resistance. Now with our total resistance, we can find our total current. So 72K and 180 volts. 72 goes into 180 2.5 times. Kilo ohms into whole volts gives us an answer in milliamps. So the total resistance is 2.5 milliamps. Or we could say that 180 volts divided by 72,000 is 0.0025, or 2.5 milliamps. Now we can tackle the voltage at test point 1, which is this point here. So we have 48K and 24K, a 2-to-1 ratio. So this voltage is twice that voltage. So that's 120 volts and 60 volts. So test point 1 is the voltage across this resistor. So test point 1 is 60 volts. And let's transfer that over to here. Now let's find the currents through these two legs here. This 24K resistor will expand out to be 40K and 60K in parallel. This resistor is 1.5 times the value of that resistor. So this current through this leg will be 1.5 times the current through this leg, or the current through this leg will be 1.5 times the current through that leg. The total current is 2.5 milliamps. So it splits with 1.5 milliamps going this way and 1 milliamp going this way. And now we have all of the currents. So the voltage at test point 2, let's look at this again. We have 60 volts and we have 40K and 20K. So that's a 2-to-1 ratio. So the voltage here is twice the voltage here, and those two voltages must add up to 60. So we have 40 volts here and 20 volts there. So the voltage at test point 2 is 20 volts. And our total current is 2.5 milliamps. Let's do some checks to double check this. So now we have 2.5 milliamps going through 48K. So 2.5 times 48 is 120. And so we start with 180, we lose 120 and have 60 left over. So we have 60 volts across these resistors. This resistor is twice that resistor, so this voltage must be twice that voltage, and they must add up to 60. So we have 40 volts across here. We start with 60, we lose 40, and have 20 left over, so the circuit adds up. Okay, here we have the same configuration, but we have some of our information missing. We don't know what R1 is, we don't know what R4 is, but we do have 80 volts for test point 1, and we know that the total current is 30 milliamps, and we already have the total resistance, which is 3.66 ohms. We need to find out what's the value of R1 and what's the value of R4, as well as our currents through these two legs and our voltage at test point 2. Go ahead and solve the video and see if you can solve the problem. Let's start by looking to see if there's any place with two pieces of information that can give us a third. So we have 6K, no voltage here, no resistance here, no current there. There's not enough information to figure out anything in this leg, but we do have 80 volts across a 4K resistor. So 80 divided by 4,000 is 0.002, or 20 milliamps. Now that we have that piece of information, let's see what that might tell us somewhere else. We have a total current of 30 milliamps. 20 milliamps goes this way, so there must be 10 milliamps going this way. Let's transfer these up here. 20 milliamps and 10 milliamps. Now we have 10 milliamps in this leg of this circuit, and there's 80 volts across it. So now we can calculate the total resistance of this leg of the circuit. And once we calculate that, we can subtract 6K to leave us with what R4 is. So 10 goes into 80 8 times. Milliamps into whole volts gives us an answer in kilo ohms. So this is a total of 8 kilo ohms here. So we subtract 6 from 8, that leaves us with 2K for R4. Now we can calculate the voltage at test point 1. 2K and 10 milliamps. 10 times 2 is 20, or milliamps times kilo ohms gives us an answer in whole volts. So 2 times 10 is 20, so we have 20 volts for test point 1. All we have left is R1, and we have 110 volts and 80 volts. So we lose 30 volts from the battery to test point 1. So 30 milliamps, 30 volts, milliamps into whole volts gives us an answer in kilo ohms. So 30 goes into 30 one time, giving us 1K for R1. Or we could say that 30 volts divided by 0.03 is 1,000. And there is our solution. Okay, here's another one like the last. We don't know R1, we don't know R4, and we do know we have 4 milliamps total current, and we have 30 volts at test point 1. Pause the video and solve for the unknown information. Okay, let's solve this one the same way. We have 30 volts and 10K. We divide the 30 volts by our 10K will give us the current through R2. So 10 goes into 30 3 times. Kilo ohms into whole volts gives us an answer in milliamps. So we have 3 milliamps here. And we can also do it this way. 30 volts divided by 10,000 equals 0.003, which is 3 milliamps. Now that we know the current through this leg, we can figure out the current through this leg because we have a total of 4 milliamps. So 3 milliamps here, 1 milliamp there equals a total of 4 milliamps. So there's our currents. Now we have 30 volts and 1 milliamp. We can calculate the total resistance between these two resistors. So 1 goes into 30 times. So there's a total of 30K. 1 milliamp into 30 volts gives us 30K. So we have 30K minus 10K means we have 20K left over. Now let's figure out what the voltage at test point 2 is. We have a 2-to-1 ratio. The voltage here must be twice the voltage here. Those two voltages must add up to 30. So that would be 20 volts and 10 volts. So the voltage at test point 2 is going to be 20 volts. Now we can go after R1. We have 90 volts here and 30 volts there, so we lose 60 volts across R1, and we have 4 milliamps flowing through it. So 60 volts divided by 4 milliamps gives us 15K, or 60 volts divided by 0.004 gives us 15,000. So this is a 15K resistor. So that one works. Let's do one more with that same configuration. So once again, we know the total resistance, we know the voltage at test point 1, we know the total current. We're looking for the value of R1, value of R4, and the currents through the legs. Pause the video and solve the problem. Okay, let's make the same approach. We have 20 volts and 200 ohms. Divide the 200 into 20. That will give us the current through R2. So 20 divided by 200 is 0.1, or 100 milliamps. So 0.1 amps is 100 milliamps. We'll put that here. And we see that our total current is 150 milliamps. So if we have 100 milliamps going through this leg, we must have 50 milliamps going through that leg. Now we can tackle the value of R4. So we have 20 volts and 50 milliamps. Divide the 50 milliamps into 20 volts. That'll give us the total resistance here. So 20 volts divided by 0.05 amps will give us a total of 400 ohms. Subtract this 300 ohms, and that leaves us with 100 ohms here. And now with that, we can tackle the voltage at test point 2. We have 20 volts and a 3-to-1 ratio. So this voltage must be 3 times that voltage, and those two voltages must add up to 20. So we must have 15 volts here and 5 volts there. So the voltage at test point 1 must be 5 volts. Now let's tackle the value of R1. We have 42.5 volts and 20 volts, so there's 22.5 volts across R1, and there's 150 milliamps flowing through it. So 22.5 volts divided by 0.15 gives us 150 ohms. Let's spot check a couple of these to make sure. We have 50 milliamps and 100 ohms. So 0.05 times 100 is 5. So there's our 5 volts there. So that is correct. And here we have 22.5 volts divided by 150 ohms. And that gives us 150 milliamps. So that all works out. That's it for this video. But the next video will be on some more complicated series parallel problems. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.